on Wednesday, we talked about the 5 kinds of chemical reactions. Okay, we talked about synthesis reactions, where 2 elements combine to form a single compound. We talked about decomposition reactions, which are the exact opposite. Okay, one compound breaks down into its component elements. Okay, we talked about combustion reactions, where a hydrocarbon, that is something that contains carbon and hydrogen, reacts with oxygen to produce carbon dioxide and water. And then we talked about the 2 replacement reactions. Single replacement, where an element reacts with an ionic compound, and double replacement, where 2 ionic compounds react and switch partners. Okay, is that ringing a bell for everybody? All right, we talked about balancing and how to balance chemical reactions, okay, and to write them out in words. So that's what we're going to be doing a lot of over the next couple of days, because by the time we get to the lab, we're going to need to be able to start predicting the products of a chemical reaction. That is, I only give you the reactants and you tell me what the products will be and you balance the reaction. Okay, we're going to have to be to that point within the next week. All right, so let's use number 1 just as a quick review here. Okay, in number 1, I start out with trinitrogen dioxide, and it breaks down into nitrogen and oxygen. What kind of reaction is that? That's a decomposition reaction. Okay, so we've written it in words, we've identified the type, and now we need to balance it. What should I start with? I should start with nitrogen because it's present in the largest number. Okay, it's usually easiest to balance the largest number first. I got 3 nitrogens over here and only have 2 over here. How am I going to make those the same? What number would they both work with? Right, okay, so I'm going to put a 3 on the product side, I'm going to put a 2 on the reactant side, okay, so a 3 here to give me how many nitrogens? 6, so the lowest common multiple is 6, that's what we're looking for, okay, now I've got 6 over here, now I've got to balance my oxygens. How many oxygens over here on the reactant side? 4, so what needs to go in front of oxygen here? 2, okay, is that ringing a bell for everybody? All right, so what I would like you to do is write down those 5, okay, including the one we just did, okay. Do them. I'll give you a few minutes to get ahead of me while I do attendance here, and then we'll have a look at them together. All right, so on number 2, I have calcium by itself, which is an element, reacting with iron 3 chloride to produce iron and calcium chloride. What kind of reaction is that going to be? Single replacement, right. Okay, so written out in words, we've got calcium plus iron, Roman numeral 3 chloride, okay? And again, guys, if there's a thing that people miss when they're writing these out in words, okay, it's that they forget to put Roman numerals on ones that need it. Now, when I write iron here, do I need to write a Roman numeral? No, because iron, when it's an element, doesn't have a what? It doesn't have a charge. When things are as an element, they have the same number of electrons and protons. Therefore, iron has no charge. You can't tell if you pick up 2 pieces of iron whether they're iron 2 or iron 3. In fact, they're more than likely a mixture of both. Okay? We're not able to tell when they're an element. Okay? In a compound, we can tell by the ratio of nonmetals to metals. Okay? So this is just iron, and then this is calcium chloride. Okay, what should I balance first? The chlorine, because right now it's the only thing that's not balanced. Okay, so we should probably start with it. All right, over here I've got 3, over there I've got 2. Lowest common multiple is 6, so if I put a 3 here, that'll take care of chlorine. Okay, a 2 here will take care of chlorine on the product or on the reactant side. But when I do these 2 things, it changes the number of calcium and iron that I have. So I need to make my calciums match by putting a 3 here, and my irons match by putting a 2 there. Okay, questions on number 2? Okay, what kind of reaction is number 3? Combustion, right. All right, this stuff is actually called hexane, okay, but if I give you one and it's got a number bigger than the prefixes we've gone over, you can just call it fuel, okay? but we'll say, and I shouldn't capitalize hexane because it's, okay, is reacting with oxygen. So guys, obviously on a quiz or a test, I would either give you the name of a compound like that, okay, so because it was beyond the prefixes we went over, or just tell you could write fuel. Okay, plus oxygen gives us carbon dioxide and water. Okay, special rules for balancing combustion reactions. I balance them in what order? Alphabetically. Okay, which also does happen to be left to right, at least on the reactant side. Okay, and then I'll have the second rule, which is the rule of 2. Okay, that means if I have an even number of carbons, which I do, I need to start my balancing with a coefficient of 2. All right, that gives me 12 carbons. So I put a 12 over here. 2 times 14 is 28. So 14 times 2 hydrogens should be 28. Everybody all right with that? Now I've got to balance my oxygens. Okay, I've got 24 oxygens here, and I've got another 14 over here. So 24 plus 14 is 38. Agreed? Okay, 38 divided by 2 should be 19. Okay, questions on number 3? No? Okay. How many people have done number 4? I'll give you a couple more minutes, and I'll do 4 and 5. Oh, and there's a 6. I forgot all about number 6. And there's a 7. Oh, my goodness. I had way more than I thought I did. And there's an 8. How about that? And a 9. Well, we'll stop at 8. Okay? Yeah, so for 6, 7, 8, 9, it actually goes to 10. These ones are the other way, right? You're given the names, and you have to write out the reaction in formula form. Okay, which is equally valid. In fact, most of the time you'll probably get them written this way. Okay, so it'll be good practice. So try 4 and 5. I'll give you a few minutes there. All right, so on number 4, I've got chlorine reacting with lithium to form lithium chloride. What kind of reaction is that? It's a synthesis reaction. Okay, only thing that's out of balance is chlorine. So I put a 2 here to balance the chlorine, but that puts lithium out of balance, so I need a 2 there, and then it should work. Questions on 4? Okay. Number 5, we got magnesium fluoride reacting with cobalt 3 nitrates to give us magnesium nitrate and cobalt 3 fluoride. All right, what kind of reaction is that? Double replacement. It's 2 ionic compounds becoming 2 different ionic compounds. So in other words, the metals are switching partners. Okay. What should I balance first? Which one? I don't have iron in this one. Yeah, I can balance fluoride or nitrate. It doesn't matter. They're both present in equal numbers. Okay, so picking either one isn't going to make any difference. All right, so we'll start with fluorine. There's 2 over here. There's 3 over there. Lowest common multiple is 6. Okay, so I need a 2 here and a 3 here. Now I've got to go and balance my metals. That gives me 3 magnesium, so I need to make a 3 here. Okay, and I've got 2 cobalts over here, so I need to put a 2 there. Now let's double check that the nitrates worked out, because we never checked those while we were going back and forth. Okay, so I've got 6 nitrates on this side. 2 times 3 is 6. Okay, and I've got 3 times 2 is 6. So it looks like everything is balanced now. Okay, questions on that one? How many people have done number 6? Okay, let's look at that one then. Okay, so when we're given the reaction in words, okay, then we have to put it in formula form. So copper 2 nitrate. The Roman numeral tells me to use the 2 plus. When I am dropping and swapping, nitrate is NO3 and it's a 1 minus. That means this is going to need brackets. So I've got CuNO3 2. And it is going to react with magnesium. Magnesium's not with anything according to that, so it's just Mg. What kind of reaction is that? That's a single replacement reaction. Magnesium is going to replace copper because they're metals. Okay? Whatever is an element has to replace whatever is like it in the ionic compound. So that means then that copper is going to wind up by itself and magnesium is going to wind up with nitrate. Does that make an ionic compound, magnesium and nitrate? Yes, it does, because nitrate's a polyatomic ion and this is a metal. Okay? But I've got to swap and drop it. Okay? So when I do that, this is going to wind up as a 2 over here. Okay, so we said that was a single replacement reaction. Do I need to do any more balancing? Nope, it's already balanced. There's 2 nitrates on each side. There's 1 magnesium and 1 copper. Okay. All right, I'll give you a few more minutes on those ones, and then we'll... Yep, do them all. Okay, so number 7, I got dodecane, C12H26. And this is probably how I would do it on a test, is I would just give you the formula and then have you just copy it, okay, as opposed to give you the name. And it's going to react with oxygen gas, and that's going to form carbon dioxide and water. I'm going to be dealing with pretty big numbers here, agreed? Yes, okay, because 12 is also an even number, which means I need to multiply it by 2, which is going to make things even bigger. All right, so I need over here 24 carbons, and over here I need 52 hydrogens. So I've got 48 oxygens in the carbon dioxide, 24 times 2, okay, plus another 26, which should give me 74, right? Okay, so I need 74 over 2 should give me 37. Yeah? I should not do math in my head. I got very lucky there that I actually got those ones right. Okay? All right. Questions on that one? Obviously, the reaction type there is combustion. Okay, number 8. I've got lithium nitride. So Li with N, that's an ionic compound, so I do need to drop and swap it before I go any further. Okay, that's going to mean Li3N. Breaks down into nitrogen and lithium. Here's where needing to remember which elements are special becomes crucial. Because if you forget that when nitrogen's by itself, it's a 2, not only will you get the products wrong, but you'll never be able to balance it correctly either. I mean, you might be able to balance it, but it won't be right. Okay, which means basically forgetting N as a 2 means you're going to get 1 out of whatever this reaction is worth if you wrote the products right. Okay, or sorry, wrote the reactants right. So we've got nitrogen, N2, and lithium, which is just Li. It's not one of the special elements. Now I've got to balance. Okay, I could go and balance the lithiums first, but if I do that, I'm just going to have to erase what I write because the nitrogens won't be balanced. So I'm going to balance the nitrogens first by putting a 2 over here. Okay, which gives me 6 lithium. And now my decomposition reaction is balanced. Okay, how many people are done 9 and 10? Okay, I'm going to give you a couple more minutes before I do 9 and 10. If you're done 9 and 10, then you can start on the worksheet that I handed out earlier. All right, let's have a look at 9 and 10 here. So number 9, I've got hydrogen sulfide. H with S, when dropped and swapped, this is a -2, that's a +1, so we're looking at H2S. Okay, reacts with calcium hydroxide, Ca with OH. Okay, OH is a -1, calcium is a +2, so this one needs brackets, OH2. Okay, is going to give us calcium sulfide, CaS, 2 and 2, so those are balanced already. Okay, and water, HOH. Why am I writing it as HOH? Right. Okay. It's still water, but I started out with OH in one spot and H in the other. It's just easier for me to balance the reaction if I write it that way, because it's easier for me to remember where everything came from than if I write it as H2O and I forget that it was made up from an OH from one thing and another. All right. So looking at this then, I'm going to start with the hydrogens. Okay. There's 2 of them over here. How many over there? Well, no. There's 1. The other one is part of OH. That's why I write it that way. It's easier for me to keep track of where this hydrogen here, came from over here. So there's 2 over here, but there's only 1 here. So now I need a 2. That just so happens to make my hydroxides, of which I started with 2, work. Okay? And that's the whole reason you start writing water as OH if you're making it from basically an acid-base reaction, which is what this is. Okay, now just double checking everything else works out. There's 1 calcium, 1 calcium, 1 sulfur, 1 sulfur. Looks like the rest of it is okay. And this is, of course, a double replacement reaction. Okay. And number 10, phosphorus reacts with oxygen. So phosphorus, is that a special element? It is. It's even more special than the person it's reacting with. Oxygen, which comes as a 2. And once again, if you don't remember that those are 4 and 2 when they're by themselves, you might get the products right, but you're never going to get it balanced right. Okay? To make triphosphorus dioxide. Okay. Now, the reason I threw this one in, I don't even know if this is a real reaction. It's probably not. Okay? But to get you thinking about big numbers and balancing, right? Oxygen's already balanced, so I have to start with phosphorus. What's the lowest common multiple of 3 and 4? 12. Okay, so 3 times 4 is 12, and 4 times 3 is 12. Now my phosphorus are balanced, but my oxygens are not. I've got 8 oxygens over there, so 4 here will take care of it. Okay, they will get tougher than that, right? But that's generally where we are headed. Of course, the next thing, like I said, will be to start predicting the products of a chemical reaction, which really isn't all that hard. You can identify the reaction just from its reactants. Figuring out what should happen is actually pretty patterned, okay, pretty straightforward. All right, so working on that worksheet that I handed out to you, okay, that looks something like this, except without the writing on it. The key for it, so that you can check it as you go and just check each question after you've done it, okay? The key is on my website. I'll put it on Google Classroom in a minute here, okay? But actually, I won't put it on in a minute, all right? Because I want to make the announcement until I have the podcast. But you can find it, okay, on my website in Science 10 stuff, okay? The only place you guys have ever gone on my website. Okay, in the chemistry folder, and it will be under Keys to All Reaction Worksheets, which is near the bottom, right here. Keys to All Reaction Worksheets. Okay, unfortunately, it is a scanned piece of paper with my writing on it, which means the writing is awful, but I can't fix it now. I'm too old.